welcome to Mass English. Today we'll be talking about the topic that says differential calculus. But before we go into that, let me just tell you briefly about calculus. The calculus is a Latin word that means pebbles, tiny stones, okay? In the ancient times, tiny stones are used for simple arithmetic calculations. So that is where we have the word calculus from. Now, calculus is actually a branch of mathematics that deals with change, that tells us how a variable changes with respect to another variable, or that tells us how how tiny things accumulate or sums up to give a large part. Okay, so and that is where we're talking about the areas under a curve, and then we're talking about the slope or the gradients of a straight line or of a curve. All these things are what calculus tries to help us define. Okay, now calculus actually has two fields. We have what we call the differential calculus, which is what we're going to be treating today, and then we have what we call the integral calculus. So the part that deals with how things change with respect to another is what we call differential calculus. And then the other part that deals with the summation of things, the accumulation of things, is what we call the integral calculus. So let's talk about the differential calculus today. Now, there are certain rules that guide the differential calculus, and I want to save us the time of trying to get the rules and the other aspect that has to do with limits and continuity. I'm going to boycott all those ones for now. Let's just go straight into the simpler part, and then maybe probably later we can come back into limits, continuity, and then can also come back into the other parts of differentiation, the other part that talks about differentiation by first principle. So today we'll be starting with this simple differential calculus that has to do with differentiation of simple polynomial forms like this, like y equal to a raised above ax raised above n. So when given something like this, how do we differentiate it? There is a rule that is guiding us. The rule says to differentiate y with respect to x, which is symbolized as dy dx, that you should take the power of the variable x, use it to multiply the coefficient, and then you subtract 1 from the power of x. That is how to differentiate any algebraic equation that is in this form. Okay, so let's see how it's being done. Let's take an example. So if you are given y, for example, y equals to 10x raised to the power of 4, how do we differentiate this? Remember, I said to differentiate simply means your dy dx. Remember, I said that differentiation has to do with, differential calculus has to do with change. Okay, it's telling us about the rate of change of y with respect to x. So how do we solve that? We use this rule. You can see that this is actually in this form here. Okay, so the rule says take the power of the variable times the coefficient. So let's go 4 times 10. That gives us 40. And then it says subtract 1 from the power. So you're having 4 minus 1. So our final answer to this is 40x raised to the power of 3. Okay, so let's take another example. So let's take example 2 now. Example 2. So in example 2, if you are given y, say y equal to minus 3x raised to the power of minus 4. Now, if we want to differentiate this, let me come here. So the y dx is going to be, remember we said, the power of the variable x should multiply the coefficient. So minus 4 times minus 3, that gives us plus 12. And then it says subtract 1 from the power, which is minus 4 minus 1. So when we subtract 1 from the power, we'll be having 12x Minus 4 minus 1 gives us minus 5. So that's the solution to that. Now let's solve one more. Let's assume you're given, so let's call this one example 3 now. So let's assume you're given y equal to 1 over 2x, and you're asked to differentiate this. Now, first of all, this is where your knowledge of indices is very important. So this is where you're going to apply your knowledge of indices to this. So this is the same thing as to say 2x raised to the power of minus 1, okay? And that is going to give us 1 over 2 x is above minus 1. Okay, so let's differentiate it now. The y, the x, minus 1 times half, that gives us minus half. Then subtract 1 from the power. So minus 1 minus 1. Okay, so let me bring it up here to write. So I'm going to have my dy dx is equal to, now let's go. This will give us minus 1 over 2 x is of minus 1 minus 1, that gives us what? Minus 2. So, and this is our final answer, or we can also take it to the fraction form. That will give us minus 1 over 2, all over x raised to the power of 4. X to the power of 2, right? I'm sorry. X to the power of 2. So this can also be the answer if you want to give it this in fraction form. So thank you for watching. I hope you gained value. So let's see in our next video. Bye.